Hi guys, I hope all is well. So we have an O-level past paper question of the year 2020. The session is May-June. This is question number 11, the last question of the paper. We'll discuss transformations, matrices, reflection and rotation. I have it in front of me. Let's start. So they've given us a graph and there are three triangles in it, A, B and C. Part A says describe fully the single transformation that maps triangle A onto triangle B. So triangle A being mapped onto triangle B does not look like a rotation, it does not look like an enlargement, neither does it look like a translation. So the only possible explanation here is that this looks like a reflection. But how? So if this point is being mapped onto this point, the distance between them is 1, 2, 3, 4, 5, 6 units. So let's draw a line right in the center first and check whether the other points are being reflected in the same line as well. So this is being mapped onto this point with 6 units difference. This is being mapped onto this point with a 12 unit difference. So this is a reflection in the line y equal to minus 1. So we write the answer there. Reflection, sorry, I don't know why I wrote the other F. It is a reflection in the line y equal to minus 1. Okay, let's move on. Triangle A is mapped onto triangle C by the single transformation H. Find the matrix representing H. Now A is being mapped onto C, which does not look like a reflection, neither does it look like a translation or an enlargement. So it can be a rotation. Let's check. So let's first connect this point right here with the origin, because we're trying to find the angle of rotation. So this, okay, then if this point is being mapped onto this point, let's draw a line from that point to the origin as well. One second. When we do that, this angle looks like a 90-degree angle. So this is a 90-degree anti-clockwise rotation. Now it says find the matrix representing H. If I draw a small graph as an example, and if there is a point here that is 1 and 0, if this point is being rotated anti-clockwise onto this point, the coordinates of this point would be 0 and 1. That means if I write down the points in H, the first point would be 0, the second one would be 1. If I further rotate this anti-clockwise 90 degrees about the origin, it would become minus 1 and 0. So the other points are minus 1 and 0. This is the matrix for this rotation. So I write the coordinates, the points over here. Excellent. Let's move on. Transformation M is a reflection in the line x equal to 2. Okay. Transformation R is a rotation 180 degrees about 0 and 0. Triangle A is mapped onto triangle D such that RM A is equal to D. Draw and label the triangle D. First, we will need to reflect A in the line x equal to 2. Let's do that. So first, let's erase all of this stuff so that we can do the last part easily. Perfect. Now let's reflect triangle A in the line x equal to 2. So the line is going to be somewhere, one second, here. Okay. So the point, this point would be reflected to this point. This would be reflected to this point, and this would be reflected to this point. So we have our triangle, we can call that A naught. Now this needs to be rotated 180 degrees about the origin. Okay, so about this point, so there are 2 units here, so there will be 2 units here for the first point. Then since this makes an inverted L, this is going to make an inverted L here, so this point maps here, and then this point maps onto this point. Let's connect these points and we have our triangle D. I hope the question made sense. The complete working of the entire question is present in the description below for you to download. If you like the video, hit the subscribe button and thank you for watching.